Okay, friends, this is an exciting day because this is one of the most important lessons in math concepts that you will learn for the rest of your mathematical career. What we're going to learn today is trigonometric ratios. Okay, trigonometric ratios. So ratios specific to triangles, and trigonometry is the word that we use in math that specifically refers to measurement of triangles, understanding how to measure different parts of triangles. So what we have here is a lesson on trigonometric ratios. I've included the notes on PowerSchool. This might be one of those lessons where it's really important to go ahead and print off the notes first. So if you need to pause the video and go print off this PDF before watching this video, that is totally fine. In fact, I would suggest doing that so that you can spend more time listening and less time writing. But with that being said, we're going to get right into it. So we have this triangle right here, ABC, and we have three angles. I want to distinguish each of these things first. We have three angles, A, B, and C. And A, B, and C are all angles. Okay. Then we have three sides, which are little a, little b, and little c. Okay. So three angles, three sides. That's what makes up a triangle. You can see this is a right triangle right here. So these are our three trigonometric ratios, and their names are sine, cosine, and tangent. And these are all special types of ratios that pertain specifically to triangles. So we have sine, cosine, and tangent. So you can think of these like almost like the quadratic formula or the distance formula. They are these ratios that will be the same for all angles in all triangles. Sine of one triangle, of one angle of one triangle, will be this exact same concept and same ratio in another triangle. Okay? And so you can see what sine, cosine, and tangent are here. And when we take a trigonometric ratio, we take the ratio from the perspective of an angle. So you can see here, this is sine of A. Sine of A. So we're looking from the perspective of angle A. Okay, so this is just the sine, cosine, and tangent ratios just from the perspective of angle A. Okay, so sine of angle A, this ratio, sine of A, is the length of the side opposite A over or divided by the length of the hypotenuse. So let's actually write this out specific to our triangle here. Sine of A is the length of the side opposite A. Well, if we're looking from the perspective of angle A, which side is opposite A? Well, if I look, the side opposite A is clearly little a, and I'm going to be dividing that by the length of the hypotenuse. Well, of course, in this right triangle, the hypotenuse is always going to be little c. So specific to this triangle, sine of A is little a divided by little c. That's the ratio between in this triangle that is sine of A, that we call sine of A. Cosine of A is the length of the side adjacent to A. So the length of the side that is touching A, there's two sides touching A, that's not the hypotenuse, is called the adjacent. Okay, is called the adjacent. This is opposite. We call this side the adjacent side. It's the side that's touching this angle A that's not the hypotenuse. So the length of the side adjacent to A is clearly little b divided by the length of the hypotenuse. Okay, so in our triangle that would be specifically b over c. And tangent of A is the length of the side opposite A, which we've already talked about, is little a. And the length of the side adjacent to angle A, which is little b. And those are our three ratios as they pertain to this angle A. Sine of A in this picture is A over C. Cosine of A is B over C, and tangent of A is A over B. And sine, cosine, and tangent of any angle will always be these exact same ratios. So for example, we could do all of this same thing and find the sine, cosine, and tangent of A. Would it be exactly like this? Not quite. Why? Because now if I'm looking from the perspective of angle B, what my adjacent and what my opposite are would change. So now if I'm looking for the perspective of angle B, this side, little b, would become the opposite of that angle, and A would become the adjacent. Okay? So it's really, really important to always remember that this all depends on the angle that I'm looking from. Am I looking from angle A? Am I looking from angle B? That determines what my sine, cosine, and tangent ratios are. All right? So we're going to get a little bit of practice at this. First of all, how are you going to remember these? I don't care how you remember these, but I'll tell you this right now. You need to memorize these ratios. However you need to memorize them. You probably have all heard of multiple. I'm going to tell you about one in a second. I don't care how you do it. I think it's just easiest to memorize. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. The commonly referred to way to memorize this is SOHCAHTOA. SOHCAHTOA. Okay? And what that stands for, SOHCAHTOA stands for, is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay? So you can see how SOHCAHTOA is a mnemonic. It's a memorization tool to remember what sine, cosine, and tangent are. So we're going to get some practice. Here we have another triangle, but now we're given the sides 6 and 8. And the first thing that we actually need to do is we're going to go ahead and find what the hypotenuse is. So if I know both of the legs of a right triangle and I'm looking for the hypotenuse, then I can use the Pythagorean theorem. So we're going to do 8 squared plus plus 6 squared equals c squared, and then we're going to solve for c. 8 squared is 64, 6 squared is 36. I'm going to come over here to finish this. So 100 equals c squared. So when I take the square root of both sides, we find that c is 10. All right, so we know c is 10, and now we're being asked to find, well, what is sine of A, what is cosine of A, what is tangent of A, what is sine of B, what is cosine of B, what is tangent of B? Okay, so first we're asked, let's just handle all of the A's. So first we're asked to find sine of A. What is sine of A? Well, sine of A, if we look up here, is opposite over hypotenuse. So once again, I have my little smiley face here. I need to look from the perspective of my smiley face. The side that's opposite angle A is 6. So this is going to be opposite over hypotenuse. And the side that's opposite is 6, and the hypotenuse is 10. So sine of A is 6 over 10, or 0.6. You can write it either way. Cosine of A is adjacent over hypotenuse, and the side that is adjacent to A is 8, and then the hypotenuse is still 10. Doesn't change, or 0.8 if you want to think about it that way. And tangent is opposite over adjacent, and like we've already talked about, opposite, the side that's opposite of A is 6, and the side that's adjacent to A is 8. So opposite over adjacent would be 6 over 8. And there you have it. That is sine, cosine, and tangent of angle A. Sine of A is 6 over 10, cosine of A is 8 over 10, and tangent of A is 6 over 8. But now, if we look from the perspective of angle B, like I just implied on the last side, now these things kind of change. If I'm looking for sine of B is opposite over hypotenuse. Well, looking from the perspective of angle B, 8 is now the opposite, and 10 is the hypotenuse, right? And now I need to find cosine, which, if you remember, cosine is adjacent over hypotenuse. Well, the side that's adjacent to B is 6, and then the hypotenuse is still 10. And then I need to find tangent, which is opposite over adjacent. Well, opposite of B is 8, and adjacent to B is 6. So that would be our sine, cosine, and tangent ratios for both angles A and B. And you can notice how sine of A and sine of B definitely aren't the same thing, but interesting, cosine of A and sine of B are the same thing. Maybe something to keep in mind as we go forward. So here's what I want you to do. You have this problem here in your notes. I want you to go ahead and pause the video and do this one on your own, and then check your answers with a partner that's near you to make sure that you got the same thing. Okay? So go ahead and pause the video, do this one on your own, and then check with someone else. And then when you're ready, we'll continue on. So hopefully you've done this one already. The first thing that you needed to do was to find what this side, we'll call it B, was by doing the Pythagorean theorem. I'm actually not going to do this here, but that should have been your first step, would be to set up 6 squared plus B squared equals 8 squared, and then solve from there. And then you can look from the perspective of A, find those ratios, look from the perspective of B, find those ratios, and move forward. How do we use trigonometry? Well, this is an important question, and we use trigonometry to give us a semblance of what's the relationship between sides and angles. Okay, so we use trigonometry basically to help us find the lengths of sides of triangles. Okay, so remember, when we take the sine, cosine, and tangent of something, when we're looking for those ratios, we're doing that of angles. So I can actually do some of this math here in my calculator. Okay, so if I were to ask to find the sine of 37 degrees, I can do that in my calculator. Now, I have this note to point out that mode is really important. When you go to mode on your calculator, you need to make sure that your calculator is in degree mode. So if you hit mode on your calculator, about the third row, you will see radian and you will see degree. And in order to get these questions right, in order to get these calculations right, you need to go down, hover over degree, and hit enter, because your calculator has to be in degree mode. But I can take the sine, cosine, and tangent. You'll see them on your calculator of these numbers. So this calculator is in degree mode. So I'm going to type in 37, and then I'm going to take the sine of 37, and I get 0.6. I'm just going to include that there. Now, let's think about what that means for a second. What this means is this is a ratio. What is this ratio? It's sine, so that's the ratio of the opposite over hypotenuse. So the ratio of an angle in a triangle that measures 37 degrees is 0.6. The ratio of the opposite side to the hypotenuse of a 37-degree angle is going to be 0.6. Well, we can go back and we can do this for cosine of 17. I'm going to clear this. I'm going to type in 17 and hit cosine, and we get 0.96. So what does this mean? Well, this means that the ratio of the adjacent side to a hypotenuse of a 17-degree angle is 0.96. That's almost 1. What does that mean? Well, if you remember, if I have a side length of 10 and a side length of 10, that ratio would be 1. So because this is close to 1, what we can tell is that the ratio of a 17-degree angle of the adjacent side to the hypotenuse side is almost the same thing. It's not quite the same thing. In fact, the adjacent side is going to be a little bit smaller than the hypotenuse, but it's almost the same thing. And then we can do the same calculation for tangent as well. I'll type in 68. I'm going to hit tangent, and I get 2.48 as my ratio. Okay, so, and let me just double check that to make sure that's right. Yep, okay. So when you do this in your calculator, you will need to hit tangent, sine, cosine, or tangent first. So you'll hit sine, the sine button, an open paren will come up, and then you can just type in 37 degrees and then hit enter and you'll get your answer. But remember, it's really important that your calculator is already in degree mode, not in radian mode. Okay? So last slide, we're almost done. What we have here is an example problem of how we can actually use sine, cosine, and tangent to find the lengths of sides. Okay, so let's say that we're given a triangle and this is what we know. Well, we can actually set up a sine, cosine, or tangent ratio to help us solve. So let's do this. Let's set up sine and cosine of this angle A. But we know what angle A is. And angle A is 35 degrees. And remember, sine of 35 degrees, like we just saw, is just a number. It's a number that I can calculate on my calculator. So sine of 35 degrees is going to be opposite over hypotenuse. Well, this equals A over 8. Opposite over hypotenuse in this case is going to be A, which we don't know, over 8. Well, here's the cool thing about this. This is a solvable algebraic problem. I can actually solve this for A. Anytime I have a variable that's in a fraction and I want to get rid of that fraction, what I need to do is I need to multiply both sides by whatever is in the denominator of that fraction. Why? Well, here we have A over 8. I want to get A by itself, so I need to get rid of this fraction. Okay, so what do we need to do? Well, like I just said, we need to multiply both sides by what's in the denominator of this fraction. 8's in the denominator, so I'm going to multiply both sides by 8, just like that. And what happens over here when I do that is these 8's actually cross out. And what I'm left with is A equals 8 sine of 35. And that's actually a number that I can find in my calculator. This is a way for us to find the length of A. Okay, so I'm going to pull up my calculator again, and I'm going to type in, what you should do is you should type it in your calculator just like this. It's going to look a little bit different on my screen, but I'm going to find the sine of 35, and then I'm going to multiply that by 8, and what I get is I'm going to round it to 4.6, that A is 4.6. And there we found a length for A. Now, I could go two routes now to find B. Now that I know two sides of a right triangle, of course, I could always use the Pythagorean theorem and do A squared plus B squared equals C squared. But just for practice sake, I think it would be helpful for us to actually set up a different trigonometric function to find trigonometric ratio to find B. Now, when we're trying to figure out how we should do this, so I'm going to erase this so I can give myself this space back. Okay, but you should have that in your notes. And we're going to remember that this is 4.6. Now, when I'm trying to figure out which ratio should I use to help me solve, you always need to look at what do you want to know and what do you know. So we know 35, so we're always going to be looking from the perspective of that angle in this case. We already know A. What we want to know is B. Well, what side is B? B is adjacent, and what we already know is this side, which is the hypotenuse. So adjacent and hypotenuse, what ratio is that? Well, that very clearly is cosine. So we're going to set up the cosine ratio to help us solve. So I need to set up cosine. Cosine of 35 is adjacent, which in our case is B. B is the adjacent side to 35 over the hypotenuse, which is 8. And once again, we have the same dilemma. We want to solve for B. What I want to know is in a fraction, so I need to multiply both sides by what's in the denominator of that fraction. Those cross out, and I would get that B is 8 times the cosine of 35. And that's something that we can plug into our calculator. And we get that B is 6 6.6. Now, guess what you would have gotten if you had stopped and done the Pythagorean theorem with 4.6 and 8? You would get 6.6, and we can double check our work really quickly. Now remember, we rounded, so if we use these numbers, we won't get exactly 8, but we should get something close because remember, these numbers were really long and we had to round. So we have 6.6 times 6.6, that equals 43.6, plus 4.6 squared equals 64.72, and when I take the square root of both of those sides, I get 8.04, which is really close to 8, which kind of tells us that we're on the right track. Very good. So what I want you to do here, now these are going to be a little bit different, but I want you to try and set up the sine, cosine, and tangent ratios for angle M and see which one of those you can use to help you solve for these sides N and P. And then I want you to try and do that. I want you to try and do that on your own. Try your best. If you don't get it right, this is hard. Trigonometric ratios are a difficult concept. We're going to get lots of practice with them, I promise, so don't worry. But try your best and then check with someone around you. And when I come back on Tuesday, what we will do is we will go through and we will check these as well. Okay. I've also posted the practice problems on PowerSchool for the section 9.5. Once again, try your best. It's not that many problems. Try your best. I will have access to my email over the next few days. So if you have any questions or are confused on anything, don't hesitate to email me. In fact, I'll probably get back to you really quickly, even if it's in class. So don't hesitate to reach out. Do your best. Understand this about this, guys. These are difficult concepts, okay? If it doesn't seem like it's clicking the first time you're doing it, that's okay. It doesn't mean you're bad at math or that you're never going to get this. These trigonometric ratios take a lot of practice, and like I said, no matter what you do, you need to memorize these to the best that you can. And really, to be honest with you guys, until you memorize these are kind of going to be a struggle. They're going to be difficult for you, and they're going to seem like this amorphous concept that's really hard to kind of get a grapple on. So just do your best. And if you don't get all these questions right, who cares? It means you're still learning, okay? So do your best, and I look forward to seeing you when we return next week.